Vertex form, y equals a times x minus h squared plus k. The minimum value of the perfect square x minus h squared is 0. Exercises. Determine the value of x that minimizes the function. F of x equals x minus 2 squared is smallest in value when x equals 2. That would make this whole thing 0. So f of 2 equals 0. G of x equals x plus 5 squared is minimized when x equals negative 5. If we put negative 5 in here, then this whole thing becomes 0. The maximum value of negative x minus h squared is 0. Determine the value of x that maximizes the function. So f of x equals negative x minus 3 squared is smallest in value when x equals 3. If you plug 3 in here, this becomes 0. Therefore, f of 3 equals 0. G of x equals negative x plus 7 squared is minimized when x equals negative 7. If we plug negative 7 into this function, this turns to 0 and it is minimized. The graphs of f of x equals x squared, g of x equals x minus 2 squared, and h of x equals x plus 1 squared are shown. All three are perfect squares. Let's focus on the axis of symmetry for each to see if we can make a conjecture. The axis of symmetry of f of x equals x squared is x equals 0, right here, the y-axis. The axis of symmetry of g of x equals x minus 2 squared is 2, when x equals 2. And the axis of symmetry of h of x equals x plus 1 squared is this line right here, negative 1. Can you make a conjecture about the axis of symmetry of f of x equals x minus h squared? Consider the graph of f of x equals a times x minus h squared, where a is greater than 0. Its minimum value, f of h equals a of h minus h squared equals 0, which occurs at its vertex. So if you plug in h into this function, you'll get the vertex here. H minus h is 0, which makes this the minimum point at h comma 0. Consider the graph of f of x equals a times x minus h squared, where a is less than 0. So we have a downward facing parabola. Its maximum value is right here at the vertex, and that's when x equals h, because h minus h is going to give us 0. So that's at h comma 0, the maximum point.